Hello guys, I'm a teacher Limboka Sajuga Masame. Welcome to Limboka Physics. We have a question from the TIE. It's a question 1 from exercise 6.2. We've given the density of ions, we've given the density of fluids, and we've given the mass of fluids. These questions involving Archimedes' principle and the law of flotation. These two things we are joined together and forming a compound bar that have to be submerged in water according to this question. As the underlying word in it is of most important. Let us consider the three cases here. The first case is when the wood floats alone. The second case, it is when now we have a compound bar, the wood attached by iron and forming a compound bar that floats partially in water. The third case, it is when this compound floats inside water. Let us consider the submerged part in water. We have volume of submerged part here as V sub SW, and the forces act is upright, acting moving upwards, and weight is moving downward. Then here we have after attaching this mass of iron, the wood will moving down in such a way that the volume submerged of the wood will be increasing by changing volume sub SW, and now we will have volume of iron, we will have a total volume of wood that is submerged after we attach this iron. Now our weight is equal to mass of the wood plus mass of the iron times G. Okay, our upright as usual is acting upward. Now for a third case, it is when we increasing the mass of this iron in such a way that this compound bar is floating in water or submerged in water. For this case, we will have a total volume of iron, and we will have the total volume of wood, and now this total volume of iron is equal to volume of iron at part B plus the increased volume of iron, so that the whole compound will submerged in water. Okay, and the weight, as you can see here, this is time G, time C, G. Okay, when we consider the forces that acting upwards, and when we design this problem in such a way that we will be able to find the mass of iron for the case B, and one must be added for the case C to be possible. Hence, when we consider, then we will have upright that is acting upwards plus the weight that is acting downwards, which is equal to mass times net accelerations. For the static equilibriums, our net acceleration is equal to 0. Now our upright from the first case is equal to weight W, and this is the proof for the law of flotations, which can be simply stated that the real weight is equal to the upright for a given body to float. Okay, when we refer the law of flotations above from the first part, we will have in position to find the ratio of the volume submerged to the total volume of the wood. Now the ratio will be, as you can see here below, and we consider the Archimedes principle that states that the volume of the displaced water is equal to volume of submerged parts. For case A, volume of displaced water will be equal to volume of submerged part of the wood. For part B, the volume of displaced water will be equal to the volume of submerged part of the wood plus the increased the volume of submerged part of the wood after attaching the mass of the iron. Okay, it will be also equal to the volume of the irons, because iron, it is below wood and it is surrounded by water. Okay, and for part C, the volume displaced will be equal to volume of wood now, because, and it will be also equal to volume of iron stars, because this whole compound is inside water. Okay, let us proceed with part B. For the part B, we've attached this wood with a mass of iron. Then we apply the law of flotations, and we ask to find the volume of this iron. Okay, for we define the W and the U in such a way that we will have density of water, volume of the water displaced, times G. And for the mass of the compound, it is mass of wood plus the mass of iron. Okay, and for here, from here, okay, I will have the total volumes for this compound is volume of iron, which is totally submerged in water, plus the volume of wood, which is partially submerged in water, as volume of submerged part of wood, plus from the original case, first case, plus the volume increased after attaching the mass of wood, that is for this part B. And now it is, as you can see here, then we define also mass of iron, and because mass of wood we don't have mass of iron, we define the mass of iron. Then after following the clause, these expressions and these terms, then we will take the terms, the like terms, so that to make the subject to the volume of iron, and we will follow the arrangement so that we will have this density of water, that we take it after equal signs, and we get minus here, and this mass of wood will take after the equal sign, and we'll get minus this from this left term, as you can see from here. And this our general expressions is as you can see below. If we attach the mass of this iron, because this is a compound bar, or causes the wood submerged in such a way that the volume of the submerged part of the wood will be increased by, let's say, half quarters, or the quarter of its volume, as you can see here mathematically. Or maybe we have submerged this wood after touching the iron in such a way that the upper side, or the volume out of water, is half quarter or a quarter of its original volume. Then we will have a formula that is a volume submerged now, which is below the surface of water, will be total volume minus volume that is out of water, which may be quarter or one something divided by 8. Now our general formula, for more simplicity, when we add one of the data here, the first data here, we will have the general formula as you can see here below. And when we simplify this volume of wood, we will have here mass of wood divided by density of wood, which will go downward here. And for this case, we use this volume of as a change of volume submerged of wood. And for this formula, we just use the volume below that submerged of wood by minusing the whole volume from the volume out. Then the formula will be as you can see here. Okay, let us consider the part C, when this compound is submerged in water after adding the excess volume of iron. And here we're supposed to find the added mass of ions. We refer the expression 2, and this expression 2, now we say that the volume submerged plus the change in volume submerged will be equal to volume of wood, because now the whole system is inside water. Now we will have a volume of wood and the volume of iron, that we decide to take it as volume of iron square. Okay, when we substitute these two things, we will have a general formula as you can see here. We may follow closely this mathematics to see how this general formula is resulting into this step here, this formula. Okay, we know that this total volume is equal to volume from the part B of ions plus the increased volume. Hence, if you find this the volume stars minus from the volume from part B, then you will be in position to multiply it with density of iron to get the excess mass of iron added in such a way that the compound will float in water. Okay, when we substitute the data, we will have the final answers 14.7 centimeter cubic of ions. That's the total volumes of ions when the compound is submerged in water. As this is how we say most ships of today is made up of iron or metals and wood. Thanks for watching. Like, share, comment. Don't forget to subscribe this channel for more video like this one. Thank you.